Hi, how are you? So this time I will be presenting to you the topic called trigonometric, trigonometric ratios. All right, that's it. So trigonometric ratios, especially we are concerned of the right triangle, a right triangle. So now, let me draw the right triangle here. So that's the adjacent side. That will be the opposite side and the hypotenuse. So that's the theta, which is opposite to the opposite side. So opposite to the angle theta is the opposite. And just beside the theta is the adjacent side. And the longest line from our Pythagorean theorem, the longest line of a triangle is called hypotenuse. So here are the trigonometric ratios. Opposite side over the hypotenuse side is equal to sine theta. And then adjacent side over the hypotenuse side is equal to cosine theta. And then opposite side over the adjacent side is equal to tangent theta. So remember, S, that's sine, and O, opposite, and H is hypotenuse, and C for cosine, A for adjacent, and H for hypotenuse, and T for tangent, O for opposite, and A for adjacent. So that's how the mnemonic name SOHCAHTOA. So that's how SOHCAHTOA is derived. So for our example, we will be making use of an example to solve a particular problem. So here is another triangle, the opposite and the hypotenuse. Supposing the adjacent will be 4 units and the opposite is not given, but the hypotenuse is given, and theta is 36.87 degrees. So first we will write the given. So these are the given. Now we have the adjacent, which is 4, and the hypotenuse, which is 5. And here the theta is 36.87 degrees. So the opposite is the one that we will be looking for. Now we have opposite in there and hypotenuse, so therefore we will be using sine for this one. So opposite over the hypotenuse is equal to sine theta. Now opposite over hypotenuse value is 5 is equal to sine the theta value is 36.87 degrees. So we will isolate opposite by multiplying each side by 5. That cancels out. So we will rewrite that. Opposite is now equal to 5 times sine of 36.87 degrees. So the value using the calculator is equal to 3. So here is another example. So I am again drawing a special triangle. A triangle that has both having the same side except for the hypotenuse. So the adjacent and the opposite are both of the same value. So the opposite is 7 and the adjacent is 7. So I'll just designate this as A and B, and the theta is the one that we will be looking for. Now going back to our formulas. So remember that opposite over hypotenuse is equal to sine theta, and adjacent over the hypotenuse is equal to cosine theta. Then finally, opposite over adjacent is equal to tangent theta. So we both have opposite and adjacent. Therefore, we will be making use of the tangent theta. Alright, so the solution will be opposite over adjacent is equal to tangent theta. And opposite is 7 and adjacent is 7, tangent theta. So we will be using the calculator this time to solve for the tangent theta. So 7 over 7 is 1. Okay, so we will divide both sides by tangent to remove tangent to the other side. Usually this is no longer done regularly, but just for the sake of explanation, I'm doing it. So 1 over tangent is tangent raised to the power of minus 1. Now this is found in your calculator by just pressing the shift sign for the tangent key. So for example, here 7 over 7 is equal to 1. Shift tangent, the answer will be 45 degrees. Therefore, the value for our special triangle is 45 degrees. Okay, so that's it. So once again, thank you very much for watching.